And welcome back. So in this latest video we're going to look at a new concept which is called ionization energy. So hopefully by the end of this video you should be able to give definition for different ionization energies, be able to represent them in equations, and be able to describe the different factors that contribute to the magnitude of the ionization energy. So what do you think ionization energy is? Just quickly pause the video and have a think. Okay, have you done that? Well, ionization energy is basically the energy required to turn an atom into an ion. Not quite as simple as that, but that is basically it. Okay, now it's only about the formation of positive ions. It's energy required to remove electrons. Let's have a look at a couple of definitions. Now, the first ionization energy of any element is the energy required to remove one electron from a mole of gaseous atoms of that element. All your calculations are involving the element in the gaseous state. Okay, so how do we represent that as an equation? So whatever your element is, obviously A isn't an element, I'm just doing this in a general way. You have removed one electron from your sample and therefore it forms a singularly positively charged ion, and obviously you have the electron there to balance the equation. Now you should be thinking, where have I seen this before? You have come across this in the ionization stage of mass spectrometry. Now obviously that isn't just elements, but it's the same kind of process. Now once you've removed one electron, you could potentially remove a second. So the second ionization energy is the energy required to remove one electron from each ion in a mole of gaseous singly charged positive ions of that element. Quite a mouthful. But what does this mean? It means you're starting with your A+, your singly charged positive ion, and you're removing a second electron. The second ionization energy is not the energy required to remove two electrons from an element. It is the energy required to remove the second electron. Okay, the energy required to remove two electrons would be the first ionization energy plus the second ionization energy. That's very important. Okay, so that was the first and the second ionization energies. I'm sure you can work out what the equation for the third one would be. It would just look like this, going from 2 plus to 3 plus, fourth ionization energy, fifth, sixth, etc. So they all just follow the same pattern, but just remember that each ionization energy is the energy required to remove one electron. Okay, so let's think about the different factors which would contribute to ionization energy. Now let's just have a look at a basic diagram of an atom. Now in the middle, you know you have a nucleus. In the nucleus are protons and neutrons. So overall, this nucleus has a positive charge. Now I'm not going to draw in the protons and neutrons. I'm just going to represent the nucleus as a central positive charge. Now for the sake of this explanation, I'm going to use the GCSE way of representing shells. You know from the previous videos that it's a little bit more complicated than what you did at GCSE. They have lots of different shapes depending on the subshell. But for the sake of this explanation, it is easier to use the simplified version that you did at GCSE. So you know that electrons exist in shells which orbit space around the nucleus. And you know that electrons are negatively charged. So to remove this electron, you have to overcome the energy in the attraction between the negative electron and the positive nucleus. So the magnitude of ionization energies mainly depends on the energy required to break this attraction. It's not quite as simple as this. There are some other factors, but we're going to look at them by looking at some examples. So let's start with hydrogen. Now hydrogen has one proton in its nucleus, so I'm going to say the nucleus has a charge of 1 plus. It then has one electron orbiting in the first shell. So the first ionization energy is the energy required to overcome this force of attraction, just like we've just looked at. Now if we move to helium, helium has 2 protons in the nucleus and 2 electrons orbiting in the first shell. Now the ionization energy is still the energy required to overcome this attraction, to remove one electron. But you have to consider the magnitude of this attraction. Because the nucleus has a greater positive charge, the attraction between the nucleus and this electron is greater. Therefore, the ionization energy, first ionization energy of helium is greater than that of hydrogen. So you have to consider the magnitude of the charge of the nucleus when you are looking at the values for ionization energies. Now let's look at lithium. Now lithium has 3 protons, so its nucleus has a 3 plus charge, and it has 3 electrons orbiting in 2 different shells. Now the energy required is energy to break the attraction between the outer electron and the nucleus. Now you have to be able to consider the different factors which contribute to the magnitude of this value. So yes, you have a 3 plus charge from the nucleus, but we now have 2 different shells. That electron is further from the nucleus. The atomic radii has increased. So that attraction is not as strong as you would expect from this added proton. You also have another factor to consider. Now that we're in the second shell, the electrons in the first shell are actually repelling the electrons in this outer shell, the second shell in this case. Obviously, they both have a negative charge. Like charges repel each other. Now this is what we call shielding. Now to be honest, I don't particularly like this name. It suggests that the inner electrons are protecting the nucleus, are protecting the outer electrons. But these electrons are called shielding electrons, and what they are doing in terms of ionization energy, they are repelling the outer electrons, making them easier to remove. So there are different factors which contribute to the magnitude of ionization energy. The greater the nuclear charge, the greater that attraction, then the higher the ionization energy. But the further from the nucleus the electron is, the lower the ionization energy. So just to repeat, factors you need to consider are the nuclear charge, the atomic ionic radii. We've just been looking at atoms here, but obviously for second or third ionization energies, you'll be talking about the ionic radius, and the amount of shielding. The greater the nuclear charge, the greater the ionization energy, the higher the number for the ionization energy. The bigger the radii, the smaller the ionization energy, and the greater the amount of shielding, again, the smaller the ionization energy. So you're going to have 2 more videos on ionization energy. You need to be considering these factors for the trends you're going to see. Okay, so hopefully you should now be aware of the definitions for ionization energies. You should be able to represent these ionization energies in equations. And you should be able to describe the different factors that affect the ionization energy. So make sure you've completed your notes, and I'll see you in class.